Hey guys. Today is Earth Day, so I put this slideshow together full of factual information about the planet we live on. On the right you can see Earth-chan. She's so adorable, isn't she? Anyways, we gotta protect her at all costs. You hear me? You better know where plastics actually go. Not the oceans. Not the road. Not in the grass either. Right in a recycling bin. But enough about what you should do to keep the Earth greener. Here's what you need to know about Earth. Okay, so first off, it is the third planet of the Sun. It is also the fifth largest planet in the solar system. It is smaller than the four following gas giants: Jupiter, Saturn, Uranus, Hadron and Neptune. It is however larger than the other three rocky planets, Mercury, Mars and Venus. Let us continue. It has a diameter of roughly 8,000 miles, which is equivalent to 13,000 kilometers, and is mostly round because gravity generally pulls matter into a ball. Also yes, the background is from Celebrate Our Differences, hence the Chinese music.
Our planet is unique for many different reasons, but its available water and oxygen are two defining features. Water covers about 71% of Earth's surface, with most of it being located in oceans. About a fifth of Earth's atmosphere consists of oxygen, which is provided to us by plants. Also the background is from Minecraft Earth.
While Earth orbits the Sun, the planet is simultaneously spinning around an imaginary line called an axis that runs through the core, from the North Pole, which is where you can meet Santa, to the South Pole, which isn't as known about. It takes Earth about 23,934 hours to complete a rotation on its axis and 365.26 days to complete an orbit around the Sun. Our days and years on Earth are defined by these gyrations. Pause. The "You are forgiven Germany" is in reference to when Lil Dicky says "We forgive you Germany" in Earth, which is in reference to the Nazi Party taking over Germany in 1933 until 1945. They are responsible for causing a Holocaust during World War II. So yeah, I guess you are forgiven. Earth's axis of rotation is tilted in relation to the ecliptic plane, an imaginary surface through the planet's orbit around the Sun. This means the northern and southern hemispheres will sometimes point toward or away from the Sun depending on the time of year, and this changes the amount of light the hemispheres receive, resulting in the changing seasons. Here you can see Earth-chan again, except this time around she's revealing a bit more skin. Her watermelon's are round, not flat. So boom. More evidence that the Earth is round. Also, by watermelons I am not talking about the fruit. Earth happens to orbit the Sun within the so-called Goldilocks zone, where temperatures are just right to maintain liquid water on our planet's surface. This is in reference to Goldilocks and the Three Bears, where Goldilocks breaks into a house that belongs to bears and labels things as to this or to that until it's just right. She does this for their beds and chairs. Earth's orbit is not a perfect circle, but rather a slightly oval-shaped ellipse, similar to the orbits of all the other planets in our solar system. Our planet is a bit closer to the Sun in early January and farther away in July, although this proximity has a much smaller effect on the temperatures we experience on the planet's surface than does the tilt of Earth's axis. Now here are some statistics about Earth's orbit according to NASA. The average distance from the Sun is 92,956,050 miles, which is equivalent to 149,598,262 kilometers. Its perihelion, which is the closest point in an orbit around the Sun, is 91,402,640 miles. That is equivalent to 147,098,291 kilometers. Meanwhile, its aphelion, which is the farthest point in an orbit around the Sun, is 94,509,460 miles. That is equivalent to 152,098,233 kilometers. The length of its solar day, which is its single rotation on its axis, is 23.934 hours. The length of its year, which is its single revolution around the Sun, is 365.26 days. And finally, its equatorial inclination to orbit is 23.4393 degrees. Pretty cool, right? Now, how exactly did the Earth form? Well, scientists think that Earth was formed at roughly the same time as the Sun and other planets, some 4.6 billion years ago, when the solar system coalesced from a giant, rotating cloud of gas and dust known as the solar nebula. As the nebula collapsed under the force of its own gravity, it spun faster and flattened into a disk. Most of the material in that disk was then pulled towards the center to form the Sun. Other particles within the disk collided and struck together to form even larger bodies, including Earth. Scientists think Earth started off as a waterless mass of rock, which could be true, but if so, then how did Earth end up getting the water to become the Earth we know today? We don't have a scientific answer for this. Also, the background is a neat little image of the Earth I found in collage form. Hope you like it, cause I like it too. Simone Markey, a planetary scientist of the Southwest Research Institute in Boulder, Colorado, told Space.com this about the Earth.
It was thought that because of these asteroids and comets flying around colliding with Earth, conditions on early Earth may have been hellish.
Those are his words, not mine. If you want my words on this, I will say it may have been hellish at the time of the asteroids and comets flying around and colliding with Earth, especially because it wiped out the dinosaurs we saw early on in the first age of Earth where we were cavemen. It was also hard to not think about dying due to these asteroids and comets and how they might have got you when you weren't looking.
However, analyses of minerals trapped within ancient microscopic crystals suggest that there is liquid water already present on Earth during its first 500 million years,
Markey said. Radioactive materials in the rock and increasing pressure deep within the Earth generated enough heat to melt the planet's interior, causing some chemicals to rise to the surface and form water, while others became the gases of the atmosphere. Recent evidence suggests that Earth's crust and oceans may have formed within about 200 million years after the planets took shape. Earth's core is about 4,400 miles wide, which is equivalent to 7,100 kilometers. It is slightly larger than half of the Earth's diameter and about the same size as Mars. The outermost 1,400 miles, equivalent to 2,250 kilometers of the core, are liquid, while the inner core is solid. That solid core is about 4/5 as big as Earth's moon, at some 1,600 miles, which is equivalent to 2,600 kilometers in diameter. The core is responsible for the planet's magnetic field, which helps to deflect harmful charged particles shot from the sun. Thanks for that. Above the core is Earth's mantle, which is about 1,800 miles, equivalent to 2,900 kilometers, thick. The mantle is not completely stiff but can flow slowly. Earth's crust floats on the mantle much as a piece of wood floats on water. The slow motion of rock in the mantle shuffles continents around and causes earthquakes, volcanoes and the formation of mountain ranges. Above the mantle, Earth has two kinds of crust. The dry land of the continents consists mostly of granite and other light silicate minerals, while the ocean floors are made up mostly of a dark, dense volcanic rock called basalt. Continental crust averages some 25 miles, which is equivalent to 40 kilometers thick, although it can be thinner or thicker in some areas. Oceanic crust is usually only about 5 miles, which is equivalent to 8 kilometers thick. Water fills in low areas of the basalt crust to form the world's oceans. Earth gets warmer towards its core. At the bottom of the continental crust, temperatures reach about 1,800 degrees Fahrenheit, which is identical to its 1,000 degrees Celsius temperature. It increases about 3 degrees Fahrenheit per mile, which is similar to 1 degree Celsius per kilometer below the crust. Geologists think that the temperature of Earth's outer core is about 6,700 to 7,800 degrees Fahrenheit, which is parallel to its 3,700 to 4,300 degrees Celsius temperature, and that the inner core may reach 12,600 degrees Fahrenheit, which is comparable to its 7,000 degrees Celsius temperature. That is hotter than the surface of the Sun. Earth's magnetic field is generated by currents flowing in Earth's outer core. The magnetic poles are always on the move, with the magnetic North Pole accelerating its northward motion to 24 miles, which is equivalent to 40 kilometers annually since tracking began in the 1830s. If my data is correct here, then tracking began either 193 or 184 years ago. It will likely exit North America and reach Siberia in a matter of decades. It is important to note that Siberia is in North Asia. The state closest to Siberia is Alaska, where you cannot travel there legally. It most likely is a far distance though. Earth's magnetic field is changing in other ways too. Globally, the magnetic field has weakened 10% since the 19th century according to NASA. We know this information is accurate because, come on, it's NASA. They are responsible for space travel and were also responsible for sending the first man in space to ever land on the moon. That man would end up being Neil Armstrong, and for anyone who tries saying that the moon landing was fake, I have factual information to prove you wrong. But these changes are mild compared to what Earth's magnetic field has done in the past. A few times in every million years or so, The field completely flips, with the north and south poles swapping places. The magnetic field can take anywhere from 100 to 3,000 years to complete the flip, Space.com previously reported. By the way, in case anyone was wondering, I got this information from an article I found on Space.com, which I will link in the description of the video so that you can read it and see what I left out. The strength of Earth's magnetic field decreased by about 90% when a field reversal occurred in ancient past, according to Andrew Roberts, a professor at the Australian National University. The drop makes the planet more vulnerable to solar storms and radiation, which could significantly damage satellites as well as communication and electrical infrastructure.
Hopefully, such an event is a long way in the future and we can develop future technologies to avoid huge damage,
Roberts said in a statement. What technologies we develop to deflect huge damage is uncertain yet, but will be revealed when we are put in those situations where Earth could get damaged badly from an asteroid or any other falling thing from Earth. Hopefully that doesn't happen, but just in case it does, we should know what technology to use against it. When charged particles from the Sun get trapped in Earth's magnetic field, they smash into air molecules above the magnetic poles, causing them to glow. This phenomenon is known as the auroras, the northern and southern lights.
Roughly 78% nitrogen and 21% oxygen Earth's atmosphere is, with trace amounts of water, argon, carbon dioxide and other gases. An atmosphere loaded with free oxygen no other planet in the solar system is vital to one of the other unique features of Earth, life it is.
It surrounds Earth and becomes thinner farther from the surface. Roughly 100 miles, which is equivalent to me shooting you with 60 Gray bullets I have loaded in my AK-47 2022 model. It's 160 kilometers, which is how far I will drag your body until I drop it into an acidic river. And on Earth too. The air is so thin that satellites can zip through the atmosphere with little resistance. And if you have resistance towards me, then I can't let that slide. At that point I have to run you over with my green fucking Jeep truck. Still, traces of atmosphere can be found as high as 370 miles, which is the equivalent of me raping this girl I found at the party 10 times. It's 600 kilometers, which is how far my AK-47 can shoot. Also above the planet's surface.
O sweet Mother of Jesus, we must cleanse thy cursed spirit from Chase's body. This won't be easy, everybody.
Okay. I'm up. Ugh, where was I? Ah yes. I was doing a video on the Earth. Let's get back to that. The lowest layer of the atmosphere is known as the troposphere, which is constantly in motion and why we have weather. Sunlight heats the planet's surface, causing warm air to rise into the troposphere. This air expands and cools as air pressure decreases, and because this cool air is denser than its surroundings, it then sinks and gets warmed by the Earth again. Water vapor, carbon dioxide and other gases in the atmosphere trap heat from the sun, warming Earth. Without this so-called greenhouse effect, Earth would probably be too cold for life to exist, although a runaway greenhouse effect led to the hellish conditions of Venus's current surface. Earth-orbiting satellites have shown that the upper atmosphere actually expands during the day and contracts at night due to heating and cooling. Oxygen is the most abundant element in rocks in Earth's crust, composing roughly 47% of the weight of all rock. The second most abundant element is silicon, at 27%, followed by aluminum, at 8%, iron, at 5%, calcium, at 4%, and sodium, potassium and magnesium, at about 2% each. Earth's core consists mostly of iron and nickel and potentially smaller amounts of lighter elements, such as sulfur and oxygen. The mantle is made of iron and magnesium-rich silicate rocks, which is the combination of silicon and oxygen and is known as silica. Minerals that contain silica are known as silicate materials. Humble yourself. Earth's moon is 2,159 miles, which is equivalent to 3,474 kilometers wide, about 1/4 of Earth's diameter. Our planet has one moon, while Mercury and Venus have none and all the other planets in the solar system have 2 or more, which is weird considering that in Minecraft Story Mode Season 1 Episode 6 you spawn in a world with 2 moons as you walk into a mansion where many different YouTubers are there, ranging from Captain Sparkles to Dan TDM, and you try to figure out who the killer is. But yeah, Earth is the only planet to have 1 moon. The leading explanation for how Earth's moon formed is that a giant impact knocked the raw ingredients for the moon off the primitive, molten Earth and into orbit. Scientists have suggested that the object that hit the planet had roughly 10% the mass of Earth, about the size of Mars. And if you don't know how big that is huge. And yes, that is the moon from Majora's Mask. Astronauts and scientists have learned a lot about our planet by just simply leaving it. Well, I wish I could say that, but most times launching someone into space is difficult. You also have to consider that the ship might crash land instead. From 240 miles, which is about 408 kilometers away, aboard the International Space Station, also known as the ISS, astronauts are able to observe the thin, fragile atmosphere of Earth. Meanwhile, satellites orbiting Earth can track the planet's responses to changes caused naturally and by humans on a greater scale. Satellites have been launched to detect changes in the hole in the ozone layer, monitoring cloud coverage and weather patterns, and manage humans' use of Earth's resources. Earth is the only planet in the universe known to possess life. The planet boasts several million described species, living in habitats ranging from the bottom of the deepest ocean to a few miles up into the atmosphere. Researchers think far more species remain that have yet to be described to science. Researchers suspect that other candidates for hosting life in our solar system, such as Saturn's moon Titan or Jupiter's moon Europa, could house primitive living creatures. Scientists have yet to precisely nail down exactly how our primitive ancestors first showed up on Earth, although most believe that a chemical soup on the planet gave rise to the building blocks of living organisms. The precise set of circumstances necessary to create life from a lifeless planet are pretty unlikely, according to previous Space.com reports. So it seems we got very lucky. Another theory suggests that life first evolved on the nearby planet Mars, which could once have been habitable, then traveled to Earth on meteorites hurled from the red planet by impacts from other space rocks. My guess is that the people who were living on Mars traveled to Earth in search of new life because, simply said, Mars doesn't have all the needs for human life. It doesn't have grass or water, so that means no source of food, water or oil. Their decision was worth it at the end though. Now aliens inhabit Mars because it found the new life they were searching for.
It's lucky that we ended up here, nevertheless, as certainly Earth has been a better two of the planets for sustaining life.
Biochemist Stephen Banner of the Westheimer Institute for Science and Technology in Florida told Spacecom,
if our hypothetical Martian ancestors had remained on Mars, there might not have been a story to tell.
That was exactly what I was saying. Good call. And that's pretty much it. Like I said earlier, I will be linking the full article in the description so that you can see what I missed. Hopefully you found this interesting. If you did, then like the video and please consider subscribing. It helps the algorithm a lot. And with that being said, see you on a day that isn't Earth Day.